Listen from the previous slide.
No, sir.
Okay.
All right. Okay, let's start to our class today. Okay, now you can see the slide. I hope visible from your side. So we touch first about life cycle, yeah, about HVAC or refrigeration system. Sorry, it's not chapter 2. This one is already chapter 6. Okay, actually the basic of refrigeration, I will touch also. Maybe this basic cycle of refrigeration is uh, similar to the fundamental of hatchback, so you can find there, but never mind. I will remind also at this moment. So we go first about the what is the refrigeration first. Yeah, refrigeration is the science of producing and maintaining the temperature below that of the surrounding atmosphere temperature. This means the removal of the heat from a substance to be cooled. So main refrigeration system. So if the area for the uh, refrigeration system, we can separate by divide by uh, some parameters. Yeah, so you can see we separate by air conditioning and refrigeration. So actually, this type is different. So you can see what the air conditioning will cover the parameter. So if you see, you check under the air conditioning, we should be maintain the heating, yeah, humidifying, and control of the air quality. But refrigeration is different. They have industrial refrigeration, including chemical, process industry, food preservation. But both of them, they have a similarity parameter, cooling and dehumidifying operation in air conditioning. So differentiate by heating and application of refrigeration. So refrigeration, you can see like the our fridge in the uh, uh, every house will be provided by refrigeration or fridge. Yeah. Okay, major uses. Yeah. Air conditioning, food storage, and distribution. This one is application for uh, the both there for refrigeration and also air conditioning. So actually in your project, yeah, back to your project, so we will cover all that. Yeah, so you can choose the air conditioning, you can choose food storage and distribution, food processing, chemical and process industries, petroleum special application. So it really depend on your objective, yeah. So you can choose the application. So actually the project of HVAC is wide, yeah. It's not uh, talking only for certain area. So this one is specific application, air conditioning medium size. So actually, what I want to say is in this moment, uh, anything I show in the slide will refer to your objective in your project. Yeah. So you can discuss with your supervisor what the cover and then what the topic we will develop in your project. So in this case, you can see maybe you can get some ideas from this. Yeah, air conditioning, medium size and large building. Yeah? I think not much. Yeah, I think not so the project is not so complicated, better you choose the small type of the HVAC system or refrigeration. Yeah, this one is some application is maybe is biggest area, so I think it's not suitable for your project. Yeah, but this one I want to show only for the some part in the application. So you can see, yeah, the HVAC system in the medium size, large building. So some application in the industrial air conditioning. So under the industrial, they have several part like spot heating and cooling, environmental, laboratory, printing, textile, precision part and clean room, photographic, product, computer room, and power plant. And then in special other special application like drinking fountains, dehumidifiers, ice makers, ice skating ring, construction desalting of the seawater. So from this application, maybe you can narrow your project. Yeah? So actually, from the cycle back to the cycle, actually uh, early development of the hatchback or refrigeration will replaced by a new uh, a type of the uh, refrigeration or hatchback, because they will be proposed the uh, energy consumption or other issues like the maybe it's not friendly environment. Yeah, so that one will be replaced by a new uh, uh, discovery. Yeah, new discovery. Maybe sometime they find the new of the technology and then replaced by the old one. Okay, refrigeration is sometimes used to freeze soil to facilitate acidifications. Or further use of refrigeration is in cooling heat masses of the concrete. Okay, you can see the application is actually too wide. Yeah, you can choose. So, what the project you want to develop. Concrete may be cooled by chilling the sand and gravel, water, and cement before mixing, and by embedded chilled water pipe in the concrete. This one is other application in the construction, civil construction. Okay, you can see this one also provide the refrigeration system. Okay, now we can check the air conditioning type. Yeah, they have a much model, and then the size. Yeah, so you can see non-conducted, ductable system. So non-ducted maybe the small size, type of the air conditioning system. So like split air conditioning, window air conditioning. So maybe window air conditioning already stopped for development technology, and then maybe they change or buy the split air conditioning. In the split air conditioning, they try to develop technology by the size and then by the uh, uh, maybe for the cost consuming, they try to make the high efficiency in the energy consumption also. So much optional in the split air conditioning. And then we go to the ductable system. You can see also ductable is for the biggest area of the HVAC system. So depend on the size also. Even though they try starting to develop for HVAC system from medium size and then until to larger size. So maybe from the medium also have the several types, and then in the biggest also have the several optional. Okay, vapor compression refrigeration system. Okay, Carnot cycle. Okay, we use a Carnot cycle because the refrigerant will be received, the thermal to delivery to the room, and then again they try to reject the heat absorber to the environment. So that one is one cycle condition we call the vapor compression refrigeration. Okay, this one is one schematic of the one cycle of refrigeration in the Carnot system. So engine maybe we can consider as the pump or compressor, and then we have TL mean low temperature for distribute in the area or zone, while TH is rejected heat, and then this one is considered in the system of the Carnot engine. And then for the opposite way, actually from the engine, Carnot engine is same by opposite way, is refrigeration cycle. Refrigeration cycle. Okay, this one what the component include a minimal in the basic one of the vapor compression cycle. So it should be have at least 1, 2, 3, 4, 4 component in the inside of the refrigeration, both refrigeration or uh, air conditioning system. We have compressor, condenser, evaporator, expansion valve. This one, 1, 2, 3, 4. 4, sorry, not 5. Okay, this one is the biggest type of compressor, the green one. This one is small. Small one is common use, whether in the aircon system, in the split system, or the refrigerator like the fridge. Condenser, you know what the condenser, and then part refrigeration, this one is coil. Okay, coil will be rejected heat. As you can see, the shape is similar like a radiator in the vehicle. Same, rejected the heat to the environment. This one, the other type, maybe evaporator, but this one is for delivery the cold or low temperature. So this one will be utilized in the inside of the room or space. This one the valve, throttle valve to make the low pressure. As we know, if we make the low pressure, automatically will be get the low temperature. Okay, this one cycle system. This one pump, hot. We can consider as the heat pump, and then distribute to the condenser to reduce the temperature, and then by the valve, and then we try to decrease the pressure, and then automatically we will come to the low temperature, and then we separate, distribute to the room by evaporator, and then back again to the compressor. Okay, this one example in the lab. You can see also the lab. This one cycle system of the refrigerant, and then this one similar thing when we implement into the fridge. Okay, that one, the one cycle system in the refrigeration or ecosystem. Okay, back to the our project cycle. Creating a more efficient install based off air conditioner in the residential sector can be important strategy for conserving energy, encouraging home owners to accelerate the replacement of inefficient units with new efficient unit can save operational energy. Okay, so actually the same like maybe who to can solve the problem can survive in the uh, uh, feature. So, for example, in the aircon or HVAC system, that can provide the or propose efficient unit in safe operation energy, so we can survive in the market. So, so what happened to all type of the refrigeration? Well, so we can check in the text. However, it's with any product system, the real environmental burden is the accumulation of the burden associated with the creation, use, and retirement of the product. Okay, burden mean that high consumption energy. So as we know, the refrigerant or aircon system, they will use electrical energy, will consume energy, electrical energy, from the plant. But the plant, the power plant is come from the burning energy, can be from the fossil oil or coal. So still burning system. So that one will be burn the energy and then we convert to electrical energy. So if you burn and then can be effective unsafe, unsafe in the environmental, and then the product will be retirement, retirement. So the potential benefit from replacing on air conditioner with a more efficient unit must be weighted against the added burden associated with the creation of new unit and disposal of the old unit. Just as one can calculate an economic payback period from investment in product will lower operating costs. One can also calculate an environmental payback period from expending more energy to manufacture an efficient product will save on operating energy. Okay, when we design the product, we should be propose the calculation, not only the investment cost, but also the the period, the period cycle of product. So how long so can survive in the market. So if this product only survive only 5 years, and then what happened? We should be pay a much in the investment cost is not can pay back what we invest in the early investment. Yeah? So that one should be our concerns when we design our product. In both cases, the product must be held at least as long as the payback period in order to be beneficial. If it's not benefit, it's difficult to uh, produce as efficient product. You cannot use, you consider as a efficient product. So mean it should be can allowable calculate the product can survive in the market. It's difficult to know when the replace product like air conditioners in order to minimize total environment impact and cost. Okay, reflect to our product. because I mentioned in the our project, yeah, should be relate to green technology. Yeah, so mean when we relate to green technology, mean should be minimize, minimize total environment impact and also cost, because when we consume the much energy, yeah, also cannot consider us uh, green technology, because we burn, yeah, much energy from the power plant, yeah, maybe from the fossil oil. Yeah. So that's why the product should be come with the friendly environmental. This research seeks to help consumer, manufacturer, and policymaker understand the best time for typical home owners to replace their air conditioner in order to minimize energy consumption, greenhouse gas emission, or cost to the consumer. Okay. Okay, this one is one cycle, cycle of the project meaning. Yeah, so you should be understand why you should be uh, give the product in the friendly environment or green technology. Okay, okay, what happened when we find the product is cannot survive, yeah, in the market, yeah? At any point in the lifetime of the air conditioner, homeowner has the option of replacing an older unit with a new model. One, on average, that new model will be more efficient, but manufacturing the new model consume energy and produce emission. This thesis, this project explore how different policies and strategies can be used to reduce the burden associated with the resident central air conditioner. So your project, yeah, should be mentioned, yeah, the strategy, yeah, to reduce burdens, yeah, associated with the residency central air conditioning, anything, yeah. A model was developed to investigate how to replace the schedule of the CAC impact. The first one, energy usage, GHG emission, cost to the consumer over the cost of in the 41 years period. This one is example. So the product will be maintained at least 40 years, 30 years, because we should be pay back the to replace our early investment. Yeah. So the model is then used to explore to how different policies so reflect to the green technology. The policies is a reflector green technology. Okay. Now I will touch about the load profile. So in the one cycle reflect to the green technology or friendly environment. So mean the consume energy should be low also or efficient. So the load will be related to the load profile. So what is the load profile? Okay, the load profile, the energy load profile. Here after refer simplify load profile is an estimate of the total energy demanded from the power system or subsystem over the specific period of time, hour, day, yeah. So how much the energy demand, yeah, to run operation. So you should be able to calculate the energy uh, operation. The load profile is essentially a two-dimensional chart showing the instantaneous load can be volt ampere or kilopower power in the energy in the unit kilowatt per hour over time, and represent a convenient way to visualize how the system loads change with respect to time. So reflect to time. Anything energy consuming will be reflect to the time. Note that it is distinct from the electrical load schedule. The load profile incorporate a time dimension and therefore estimate the energy demand in kilowatt per hour. instead of just the instantaneous load per power in kilowatt. So the load profile is by the time. So let's check there. For example, load profile, how much energy consumed in that power. So let's say in the first running energy in 3 hours, first 3 hours, they will consume 900 volt ampere, and then will be reduced, and then by running on that uh, uh, 10 hours will be zero, mean that they will be closed. Yeah. So that one is how we plot our energy consumption in the one cycle consuming. So maybe for example, in the fridge, we will use 24 hours, and maybe which time will be consumed higher of energy. So it's not every hour will consume much energy. Maybe because at night, we will just remain the fridge the whole night, maybe starting from 10. The person already, the occupant already sleep, and then maybe the fridge will be constant. But if we frequently open the fridge, maybe at the day, maybe will be disturbing the energy consuming. So reflect to the cooling load in the refrigeration or HVAC system. So cooling is the rate at which sensible and latent heat must be removed from the space to maintain the constant space, dry bulb, air, temperature, and humidity. Okay, when we reflect on the HVAC system, so actually we try to disperse cooling air, cool air to the space, and then we try to maintain that time. So when the peak hour, so we try to maintain, maybe is more difficult or more consume much energy to maintain, because the occupant is in peak hour, maybe will be get the high number of person will be attend under the room. Sensible heat mean that we change the air from to saturation condition within the liquid into the vapor condition. So this one is very take or consume much energy to change the phase. The stable heat into the space causes air temperature to rise, while latent heat is associated with the rise of the moisture content in the space. The building design, internal equipment, and outdoor weather the condition may affect the cooling load in a building using different heat transfer mechanism, the SI unit or watt. So actually, the weather will be effect when the consuming the energy, because the ambient energy, ambient temperature, we change or we recovery or we condition into a demand condition. So if the starting is higher to lower, so maybe take much energy. But when the ambient energy become raining, cool, from the normal condition, at night, maybe easy to the change, from the ambient into the demand temperature. So maybe not much consuming of energy. So in day operation, maybe will take much of energy compared to the night condition. That one is we call load profile. So why do the calculation? Estimating the energy demand is important for the sizing of energy storage device. For example, battery as the required capacity of such energy storage device depend on the total amount of energy that will be drawn by the load. This calculation is also useful for energy efficiency application where it's important to make estimates of the total energy used in the system. So now we can understand why we calculate the demand energy from that profile, the profile energy in the during operation. We know the energy demand or load demand. The cooling load is calculated to selected HVAC equipment that has the appropriate cooling capacity to remove heat from the zone. A zone is typically defined as an area with similar heat gains, similar temperature and humidity control requirements, or enclosed space within the building with the purpose to monitor and control the zone temperature and humidity with the single sensor. Example, thermostat. Cooling load calculation methodology take into account heat transfer by conduction, convection, and radiation. So when we calculate in the HVAC, calculate the load demand how much. So will we include all parameter. So will be that contribute the heat, and then we should be against by air conditioning. So what the parameter that against to the temperature demand? This one in the text said, radian, from the maybe from device, anything maybe from the convection, and then radiation can be from the wall. The wall absorb the thermal from the sun, and then will be uh, store the thermal in the wall, and we will calculate different when the uh, different material of the wall, like the for the case, like the store, they will dominant by the glass door. So that one should be considered in uh, uh, load demand. Okay, that one we can use the standard of ASHRAE handbook to calculate of uh, load demand in the HVAC system. Okay, this one is a parameter that influence or affect in the load energy load thermal from the uh, outside source, solar radiation, heat conduction through exterior heat, anything. Sometimes with the from the device inside, like the light, like the electronic device, for example, TV, and then a computer, anything will be contribute to against the air conditioning load, and also the occupant, person, and habit of the person who must will be produce the thermal, metabolism of the person is different, and so on. Cooling load in the air system, how much we should be against, and radiant system. So we have much parameter to consider. Okay, that's all for today. Any question? Ada soalan?
No, sir.
Ada, sir.
Tak ada. Okay. I will take your attendance, but during I take attendance, if you have any question, you can disturb me. Okay, I will call first from the S1, week 6, Amir bin Muhammad Adnan,
Yes, sir.
Azimah binti Azman,
Saya, sir.
Dolorin Danilo,
Yes, sir.
Ishaq bin Muhammad Fuzilah,
Yes, sir.
Jeremiah Darshan, sorry, Jeremiah Darshan, Jeremiah Khairil Fitri, Khairil Fitri, Madiha Farhana, Madiha Muhammad Afiq,
Yes, sir.
Moira Patirus,
Yes, sir.
Muhammad Azid,
Saya, sir.
Muhammad Aimi Zaris,
Saya, sir.
Muhammad Faris,
Saya, sir.
Muhammad Hamizan bin Adnan,
Saya, sir.
Nur Fatini,
Saya, sir.
Nurin Dwi Mega,
Saya, sir.
Wong Chun Wai.
Sir.
Okay, we go to next. Eddie Zulfikri,
Saya, sir.
Hariswar,
Yes, sir.
Haris Anak Smil,
Saya, sir.
Hazrik Hakim,
Yes, sir.
Muhammad Amir, Muhammad Amir, Muhammad Nazrin,
Ada, sir.
Muhammad Aiman bin Razak,
Ada, sir.
Muhammad Aiman bin Rosli,
Saya, sir.
Muhammad Aqil Aiman,
Saya, sir.
Muhammad Khairil Adha, Muhammad Khairil Adha,
Ada, sir.
alright. Muhammad Syahul Iqman, Muhammad Syahul, Muhammad Syafiq bin Muhammad Syarif,
Ada, sir. Ada.
Mohsin Amili,
Ada, sir.
Nurul Fatihah,
Ada, sir.
Rushan,
Ada, sir.
Sitaren,
Ada, sir.
Tan Wei Siang, Tan, oh, Tan tak ada ya. Okey, ada nama yang tak dipanggil.
Jeremiah, sir.
Ha?
Jeremiah, sir. The first group.
Oh, first group. Jeremiah. Yang
Sir, Tan
Yeah,
ada,
yes,
sir.
sir.
Dia ada chat.
Dekat chat. Tak apa. Tadi siapa tu? Jeremiah.
Yes, sir.
Okey.
Jeremiah, sir.
Okey, yang lain ada. Siapa tadi?
Sir, Madiha punya laptop tadi dia buat hal, dia terkeluar tadi.
Oh, okey.
Dia datang tadi.
Lepas tu siapa lagi? Ada lagi? Okey, kita pindah grup tadi. Grup sebelah. Grup sebelah siapa tadi?
Tan.
Oh, Tan. Tan. Okey, lain? Muhammad Syahul tak ada ya? Muhammad Amir Irfan tak ada? Alright. Okey, untuk projek kita boleh bincang dengan mentor mengenai topik yang akan awak propose. So, topik yang awak propose, tadi saya dah bagi tahu dekat slide apa yang boleh di cover. So, contohlah kan. Contoh awak buat kontainer ikan ke yang mobile. Awak pergi ke pasar ke, awak pergi ke mana-mana ke untuk digunakan. Itu pun dah consider dalam projek. So kontainer tu contohlah pakai solar cell ke kan, ataupun kontainer bukan untuk seafood, mungkin untuk minuman ke, untuk chiller pun pakai, itu pun dah consider friendly environment. So what else? Contoh awak pernah pakai baju yang boleh cooling badan. Contoh projeknya sistem aircon tapi untuk cooling awak design. Baju boleh sejuk, ada kipas ke, ada sistem aircon. Whatever. So janji relate to the environment. So when you relate to environment, so what you need is yang tadi, yang chapter tadi, yang slide tadi saya ada mention burning less burning consuming energy, itu termasuk green technology. So ada soalan tak? Ada soalan? Yang grup dengan saya siapa? Allah. Ada orang lagi dah ke?
Saya, sir.
Siapa?
Saya-
Awak siapa?
Saya
Sama?
Nurin, sir.
Nurin. Okey. Okey, nanti awak boleh bincang dengan saya, video call ke macam gini. Kita bincang nak buat apa. Okey, kita ada masa untuk bincang. Lepas ni kan lab So lab ni lah bincang pasal projek. Okey, siapa-siapa nak bincang, kita boleh bincang. Yang lain boleh cari supervisor dia, mentor dia.
Sir,
Ya.
saya ada nombor kontak untuk yang supervisor lain ke, sir?
Nanti saya share dekat WhatsApp group
Okey, sir.
Awak nak nama siapa, saya share.
Okey, sir.
Alright. So yang lain boleh bincang dengan saya bila ada masa. Sekarang pun ada masa sebenarnya kalau nak bincang. Yang grup dengan saya lah. Alright, itu saja untuk setakat ni. Kita tutup dulu our class. Yes.
Untuk grup lepas ni boleh bincang tak?
Boleh.
Okey, kalau macam tu tunggu yang semua lain itu grup dengan tolong stay sini ya.
Okey. Saya tunggu sini Okey, yang lain boleh keluar